I'm Paquette. I'm an assistant professor here at McGill University in the Department of Kinesiology and Physical Education. I'm also a member of the Centre for Interdisciplinary Research in Rehabilitation of Montreal and a member of the McGill Research Centre for Physical Activity in Health. I'm also the Axis leader for the Human Movement and Ergonomics research axis. So my research interest is to really try to understand how the brain controls locomotion, especially what we call complex locomotion. So basically when we're going around obstacle, moving around in our environment, it's not always walking straight. We have to really control our posture and adapt our locomotor patterns to the demands of the environment. So we're really interested in understanding fundamentally how does that work in the human brain. Mostly because what we know until now is basically research from animal studies, and as we are bipedal and most animals are quadrupeds, we need to understand what are the differences between our brains and the animal brains. Another objective that we have is basically following this understanding is to see whether or not there are techniques we could use either in neurorehabilitation or other techniques, for example, with brain stimulation, where we could possibly try to help either people with motor disabilities, such as people who've had brain injuries, such as in stroke, or degenerative diseases like Parkinson's disease, to try and help them maintain their mobility. So can we use specific neurorehab techniques that target these basic mechanisms to improve function? Okay, so the goal of my research and what we do in the human movement and ergonomics axis is really to improve motor function, either with what we do in motor control, understanding how the brain controls movement in general, or via ergonomics, how work-related injuries can be improved or workstations can be improved to improve general health. As well, we do quite a bit of research in biomechanics, either from a health perspective, how can we improve function for people with disabilities, or even with athletes, for example, ice hockey players, how can biomechanics be used to improve either their equipment or their techniques. The Human Movement and Ergonomics axis, our goal is really to improve health outcomes, whether it is for people with high-level performance, to optimize their performance in the general population, or even with people with impairments to really try to improve their general health status.